Let's talk a little about nested conditional statements. Conditional statements are really best in handling things that occur sometimes. So they allow different courses of action to be followed in different circumstances. This is absolutely necessary to programming well. Now you can put one conditional statement inside another. This is called nesting, and it's possible to nest to any depth. I will say, though, that more than 3 layers tends to be really hard to understand. So when you start nesting things more than 3 layers deep, that's when you need to think about whether maybe there's a better structure that could be used. The example we're going to look at here is one where deeper nesting is actually permitted, and I'll explain why it's okay in this case and not in other cases. We'll learn some simplification tricks for some nested statements later, particularly using logical operators, but that's for the next quarter of the course. Now the problem I'm going to work on is a very urgent problem in my house called feed the dog. We're going to write a program that allows the user to enter a dog's weight and prints out the amount of dog food to feed. So 5 pounds would be 1/2 to 3/5 of a cup. By the way, I actually got these numbers off the side of the dog food bag. Who measures 3/5 of a cup? 10 pounds is 3/4 to 1 cup. 20 pounds is 1 1/3 to 1 1/2, and so on. Now, the first thing we've got to think about is an interpretation issue. What are we going to do when we have dogs between 2 weights, particularly with the smaller weight sizes? And by the way, the real thing on the side of the bag actually went all the way up to 100 pounds. I just picked out the small ones. So what are we going to do? I mean, a 5-pound dog and a 10-pound dog, that's a huge difference. It's a factor of 2 in weight. So we really have to think this through carefully. So should we pick the lower figure? If a dog weighs 7.5 pounds, do we want to feed it the same as a 5-pound dog? Well, what about the higher one? Maybe a 7.5-pound dog should be fed the same as a 10-pound dog. We could pick the closest one. Now that actually might make some sense. So, for example, a 6-pound dog, we'd pick 5-pound weight, and a 9-pound dog, we'd pick a 10-pound weight. But then there's that awkward place at 7.5 pounds where you suddenly switch from the 5 to the 10 pounds. Well, maybe we should do something like an average, or maybe we should interpolate. Now, interpolation is a fancy term, but all it means is draw a line and pick a place along that line. It's a little bit beyond what we want to do in this class mathematically, but it is a possibility. Maybe we should list from the high end of the low range to the low end of the high range. Well, I guess that could work, but what if they don't intersect? And we could go from the low end of the low range to the high end of the high range, but then you're really not helping people much because they're getting this huge, huge range. Now, I know you probably think that I'm completely insane to look at all these different possibilities, but you have to realize that the way this problem was specified was not clean enough for you to be able to do it properly without some more elaboration. One of the mistakes that professional computer scientists make when they're programming is they forget to ask people who actually know things how to do them. So instead they make conclusions and they think they know better than the people who are actually experts in the field, and they just take a guess. Well, that's just not acceptable. In this case, for example, some poor little dog could be going hungry, or maybe just as bad, some poor little dog could be getting fat. So we don't want to do things wrong. Now, as it happens, the way I actually cleared up this confusion was to go back and read the dog food bag a little bit more carefully. And what it said is that if the weight is in between, you should go with the higher weight. So that's the interpretation my dogs would have liked, and that's the one we're going to use in this problem. Now, it's very important to think about your strategy when you start to implement these things. You definitely need to stay organized. Don't just start slapping things together. Now, in this case, it means you probably want to organize this computation from the lowest to the highest, or from the highest to the lowest. It can actually be done successfully either way. Let's go and actually implement this code. So I've opened up Eclipse here, and I've pre-created a project for us to use. So here it is. I've even cut and pasted the code in there. Now that was the description from the PowerPoint. It's always useful to have that around, and remember, you can put it in the comments. Let's go from smallest to largest because that's the way the PowerPoint was written. Now, we're going to have to make a comparison here between the weight and 5. In order to do that, we need to declare weight as a double. So if the weight is less than 5, we should do system out print line feed 1/2 to 3/5 cups. Okay, now Eclipse isn't happy here, and the reason it isn't happy is that we haven't given weight a value. Now, we could get input from the user, for example, and that's how we would want this program to work. But for right now, I'm just going to put in a numeric value, and we'll experiment a little bit with that when we go to making sure the program is working correctly. So, the next thing we need to do is to put in an else statement, because this will only handle weights that are less than 5. Before we do that, though, let's take a look at that conditional statement again. Now, what happens when weight is exactly equal to 5? Should we have been in this category or not? Well, the one place we're sure we should have been in this category is right there. So we definitely want to have a less than or equal. This is a form of an off by 1 bug, with being just a little bit off. It tends to cause a lot of chaos in programming. So computer scientists like me tend to be really crazy about making sure that we don't get off by these little tiny fractions, because they do have a problem. So our next case will be else if weight is less than or equal to 10. Now you'll see that we really should be indenting another position here. And the reason we should be indenting that position is because we have an else and then we have an if nested inside of it. As it turns out in Java, though, we don't usually indent it this way, as long as the structure is a simple if, else if structure, which this one is. It actually is a little nicer because it keeps the code on the screen, and because the structure is so logically simple, it doesn't get confusing. So we'll do a system out print line, feed 3/4 to 1 cup. Else if weight is less than or equal to 20, then we'll do system out print line feed. Of course, I'll have to look and see what it was. 1 1/3 to 1 1/2 cups. I see I've got an extra space between my less than or equal. Now in this case, this 40-pound case is our last case. So we'll just put an else there and no if. And then let's see, 2 1/4 to 2 1/2 cups. Now, in order to make sure this is working correctly, one thing we need to do is to test all the cases. This is incredibly critical when you have nested statements, to make sure that you try every single one. So even though the structure is pretty simple, we need to make sure they're all working. So for example, instead of starting at 5.2, let's start at 4.7. Now when we test this, we should see feed 1 1/2 to 3/5 cups. Which we did. Now I'm going to go and test one right after the next. So maybe 6.2. This should be feed 3/4 to 1 cup. This type of cautiousness of looking through every possible case really pays off big in programming. Much easier to find mistakes when there are just a few lines of code. So we could go through and step through every single one at a time. Now, one thing you may have noticed when I was creating these is that I put curly braces around every single one of my if-else's. Now, this is a personal preference, and not everybody in computer science agrees with this. But let me show you what happens if you decide not to do that. So I'm going to take these away, and actually, because there's only one statement in each one, it wasn't necessary to have the curly braces there. So this is perfectly legal code. And by the way, the people who prefer to do code this way, their usual argument is that it's shorter. But let me show you what tends to happen. So it looks, particularly if you don't look too carefully, like what I'm doing here is having it print out that's a lot of food, just in the case when it's 2 1/4 and 2 1/2 cups, because of the way I have it indented. Well, let's put in a little teeny tiny dog weight, like 2.3 pounds, and see what happens. Well, notice it printed out that's a lot of food. The problem here is that Java doesn't read indentation. It reads curly braces. And if there aren't any curly braces, it puts just one statement in the body of each part. This mistake is incredibly hard to find. Now I realize we have just a few lines of code on the screen, and probably you saw it coming from a mile away. But when you make this mistake in a program, it can really be tough to deal with. After having a really bad day one day looking for this mistake, I decided that every time I write code, I'm just going to put in curly braces. And if people don't like it, that's their problem, because my code will be correct. And I will know my code is correct, and I won't have to spend time debugging this mistake. Now, this is part of something that's really important in computer science, and in fact, for almost any professional, that's what's called being a reflective practitioner. That is, anytime you make a mistake or have a problem in your program, it really pays to stop and think, what did I do, or what could I do in the future to prevent this mistake from happening again? If you do this over the course of a lifetime, you will become better and better at your job as you move along. So I highly recommend it. Now, I will say it also applies when you have a big success, but most people spend plenty of time contemplating their successes, and they don't always think through their failures so closely. And I have to say, I'm afraid I've learned a lot more from my failures than I've learned from my successes. So let's run our program again and see if we fixed it. And of course we have, as you probably suspected by now. Here's the scoop on indentation and curly braces. Lining up if and else at the left-hand side is okay if the structure is simple. What I mean by simple is, in this case, for example, we had an if, else if, else if, else if. No other structure in there. That's the case where you're allowed to not indent at the left-hand side. And also remember that the curly braces are optional when you have a single statement, but that I highly recommend them. So keep programming.